Thank you so much, everyone. I'm glad you all stuck around for my talk. We're going to be going over some cross-platform development tools, talk about one that we are working on at Ionic and why I think it's going to be a better tool for the future. So we're going to have a little bit of a history lesson to kind of figure out where did we come from when we think about cross-platform development. It's a pretty new topic, but it has a lot of early pieces of information that exist way back in the very beginning of mobile phones and the very first iPhone. We'll look at some of these current kind of options that you have out there for building cross-platform apps, and then we'll dive into the project that we're working on called Capacitor. So if we rewind the clock and go back to 2008, we had the original iPhone that was released. And that very first iPhone had no apps, had no SDK, and developers were told that if they wanted to build apps for the iPhone, they were going to be building them with web technologies. Now, 2008, if we can think about the very first web apps that we could use back then, probably the most influential one was Google Maps. But the web at that point in time was nowhere near capable of delivering really good performance, really great apps. So a year later, they basically backtracked and said, okay, well, we'll create like some kind of native SDK and some native tooling, and you can build apps the same way that we build apps for iPhone. And developers were more or less okay with that. A year later, the first Android device was released. And with Android OS, we have yet another SDK released in 2009. It allowed developers to use their existing Java skills and basically build apps for Android and support all of the different options of devices that they have out there. Now, between these two tools, or these two platforms and these two different SDKs, there is roughly 10 years of tooling when you think of the actual SDKs themselves, and then another 5 or so years of tooling that can come from the desktop world, where iOS was using Objective-C or Apple was using Objective-C for Mac apps. Android and Java, or Java itself, was being used for Java applets and much more enterprise-focused applications. So there's a lot of history and there's a lot of evolution of tooling that exists here. And when we look at these ecosystems today, they're far more advanced than what they were 10 years ago, and even 5 years ago, really. So since these native SDKs came out, there's always been people who have been trying to hack on it, figure out what can we do to write web apps and ship them to these stores. One of the big benefits of shipping things to a store is that there is financial incentives there. People will buy things, people will download them and install them, and you can get a cut of that. So web developers and hackers have been trying to get their web apps into a native store and take advantage of these opportunities. And this brings us to our very first player in this space. As far as I know, it's the very first one, and it's called Cordova. Now, if you've used Ionic before, Cordova has been something that you are aware of or have used extensively even before Ionic. But in a nutshell, Cordova was this idea that you could take a web app, use some kind of non-standard APIs or some standard APIs, and then deploy it to these wrapper libraries for iOS and Android, and it would polyfill and inject the native functionality needed to run on those platforms. Cordova really was a a big pusher in the idea that they should polyfill certain things. And if a web API works in a native landscape, they shouldn't do anything. They were trying to get everyone to just say, hey, this is only helping us until the web catches up. When the web does catch up and we no longer need these things, they wanted to just kind of not exist anymore, which is a very, very nice goal to have. The platform evolved fast enough, or evolved enough to where all these features exist in the browser. Why use Cordova anymore? So that was their goal. And from like a quick 10,000 feet architectural view, it exists where you have your web app inside of a web view. So have this browser, there is no back buttons, forward buttons. And from that web view in native, there was this bridge. Now this bridge would intercept calls from the web view and then pass that down to the underlying hardware and device features. So if you want to call Bluetooth, you would call a JavaScript method in your web app. That would be caught by the web view. The web view would then call the bridge. The bridge would make its necessary calls to the hardware and device features, get the data that it wants, and then return that back to the web view. And then the web view would pass that into the into your web app. So it's a pretty nice kind of, more or less of a pub sub kind of concept where things would get published out and then it would get dropped right back into the web app once those values have been returned. Some pretty common ways that this was used. For example, this is the camera API, where we would call get picture, pass in a success and fail callback, and then options that you want to pass to that camera call. Now, when that data would be returned from the camera, on success would call, and then here we're just setting the source to some giant base64 string. And then on failure, we will just handle it as we need to with an alert. Now, if you want to go ahead and do things basically on startup, there was a little hack that you had to do. Because of that web view and that bridge technology, there was a small delay between when you could call native methods or where you could call device features. So what they did was create this thing called device ready. There we go. I just slides lagged a little bit. So they created this thing called device ready where it would publish an event from native into the web view. And then as soon as that call was ready, they would just start calling different methods. So you could call, for example, get geolocation once device is ready, and then start to queue up all these methods more or less on startup. So there was like a slight delay, and on older devices, this was super noticeable. But on more modern devices like your iPhones and your modern Pixel devices, this delay is sub 500 milliseconds or sub 200 milliseconds, depending on the device. Now, for the longest time, this was probably one of the best solutions. There were other ones that existed and came into creation, but Cordova really solved a lot of these problems, and we get to see a lot of players build on Cordova and create different deployment targets. So first was iOS. Shortly after, there was Android. Then some Microsoft folks came in and contributed a Windows version. BlackBerry folks created a BlackBerry version. Samsung with theirs. So there were a lot of different players involved. And over the times, as these other platforms have kind of fallen out of favor, we've landed with iOS, Android, Windows, Electron, and Macos as the standard kind of targets that you can build for, which I think covers most modern platforms. And with this, they were able to create a huge amount of plugins. So if you wanted to access Face ID, there's probably going to be a plugin out for that. Any hardware feature or any device feature that existed, chances are there was going to be a plugin that you could just add into your project, and it would solve those problems for you. There are some edge cases though with this approach, and a lot of it had to do with the fact that it was created 10 years ago. there was a lot of custom tooling that the Cordova team created to achieve everything that they wanted, but it was really not great. If you were to say push a project up to a Git repository and then have a coworker clone that project and then try to get up and running, they would have no context of how is this app going to be signed, what plugins do I need, what platforms do I even need. They typically treated all these native platforms as build targets. So you would build for iOS and then extract the iOS binary out of there, and then you don't need the Xcode project anymore. You can just delete that and ignore it. And that works fine when there were when push notifications weren't a thing. But as iOS has become more advanced, Android has become more advanced, and there are all these new features, in-app purchases, push notifications, what have you, there needs to be some kind of centralized source of where this data exists, where these features are declared. And currently, Cordova doesn't have a really good solution for that. The project itself has also seen a significant drop in contributors. So a lot of the times, these big companies would come in and send 2, 3, 4 developers to go work on it, but then priorities change, people want to go focus on other things, people leave companies, and those contributors have no real guarantee to work on them, so they just leave. I think now the last major drop in contributors happened about 2 years ago, and to this day, there are still contributors working to Cordova, but there's nowhere near as many as there were like 3, 4 years ago. I know this is Angular, but we are going to talk about some React stuff. More or less, we're going to talk about React Native, and not just React Native, but similar projects where there is a promise of write once and you get native components. Now, I will say React Native does have a pretty good catchline with this learn once and write anywhere, but this concept, the concept itself is a little tongue-in-cheek. It's not really true. They have this promise of a truly native app where they abstract over all of these components with their own custom components. And then at build time, they will interpret that JavaScript and generate the components for you at runtime. So when people say, oh, it's a truly native app, it compiles away all of your JavaScript and just gives you something truly native. It's kind of false. They give you essentially the same architecture that you would get from Cordova. Slightly different details in how that works, but it's the same kind of setup. So instead of there being a web view, instead we have V8 on Android and JS Core on iOS. Now it interprets your app, which essentially is all written in JavaScript. And then from that actual runtime, they make calls to yet another bridge technology. So this bridge will go out, call the hardware and device features, return the values, and then send that back into the app. Meanwhile, it's generating the buttons, the images, headers, what have you, your entire app UI on the fly as it's needed. So similar-ish setup with some internal details that are a little bit different. Now, this can work pretty well. I've written a few React Native apps just to know how it works. For example, if you want to go ahead and just create a glorified div with some text that says hello world, it's fairly simple. We're just creating a component and returning some representation of what this view looks like. Where it gets pretty interesting and complex is doing things like any device features. For example, camera. To do this, I actually had to bring in a third-party library. Access things like the camera or other device-specific features, you either have to create those components yourselves, use the very low-level components that they create and compose everything together, or rely on third-party dependencies, which kind of defeats the whole purpose, in my opinion. So I know I said Cordova has some issues where there were people, where it's all contributors who are just doing it out of the kindness of their heart, you would think that having a company behind this product would be a benefit. And I still see this kind of as a downside. Because these companies have a financial interest in seeing this project succeed, if it doesn't succeed or if it doesn't fit into their needs, who's to say that this project is going to exist in the future? These other company ecosystems and projects have a much smaller community. So if you're going to try to do something or run into issues, chances are you're going to have a lot harder time finding help and support. And at the end of the day, you really do need to know a lot more about the native layers than they promise. So yeah, it's not as cross-platform as advertised. You're still writing some Objective-C, Swift, Java, Kotlin, still writing these native languages when you need to. What about Capacitor? So Capacitor is our attempt at taking the best of React Native and these other technologies and Cordova and combining it together. So on one end, you have this very web-centric way of doing things, where there is where there are imports. You're importing a JavaScript library, adding those features, and calling those native capabilities. And on the native side, it's using native tooling and native features to enable all these capabilities. At a high level, it still has that same architectural overview that you would get from Cordova, where there are some smaller details into how that bridge connects to the web view. It doesn't provide your own components, so chances are you're going to want a component library. If that happens to be Ionic, that's great. But you could also use things like Angular Material, Clarity, what have you. There's other libraries out there that you can bring in and solve all these problems. The API is not one-to-one for what a standard web API. For example, the camera API is 100% something that we created, but under the hood, it does call the get user media object. And the version support that you want that we get from this is much more aggressive than what you would get from Cordova or even React Native. We support the latest 2 versions of iOS, so iOS 13 and iOS 12, and Android 5.0 and up, which I think these days, Android 4 is less than 3%, and Android 5 is under 10%. So I think that's a fine version range to support. But let's go in and take a look at what these APIs and how this actually works. So I have a web app running here. This is built with Ionic. Like I said, you don't need to use Ionic to make this work, but this is just what I'm comfortable with. And it's running using library load server in the background. So let's go ahead and open up our tab 1 page, our page with component. So we have 2 different ways of creating and interacting with Capacitor. So what we're going to want to do is enable local notifications for this app. So we're going to create some destructured, we're going to destructure the plugins object and pull out some variables here. So we're going to want local notifications and let's actually add the equal sign there. And then we're just going to say request. We're just going to request permission for local notifications. So let's see if this works. So mind you, I'm running in the browser. Haven't even touched native yet, and I'm already talking about notifications and being able to enable that. So the website localhost would like to show alerts and notifications. Sure, let's allow that. So we're getting somewhere. We're moving really quickly. We just have notifications set up. But I have this button to schedule a notification. This says add notification. Let's go ahead and implement that again. So I'm just going to copy this and then come down into my app. And we're just going to, through the power of snippets, create a new notification. Now, this notification is just going to have a title and some body, which could be anything, an ID, and then we're going to schedule it to happen 5 seconds after I've created it. We can attach some sounds, different file attachments, create some action types, and then anything extra that we want to add to this. So this is all just kind of pulled in information from our docs. You don't need to know all of this right at the moment, but you could actually build out all these features and have this run in the browser. So we'll save, go back to our browser. Since I've already requested permissions for notifications, I'm not going to get prompted again, but let's just add a notification to the schedule. I'll wait around, give it like 5 seconds, and hey, we got a notification coming up here, and this is just using the web. Chrome, try the same thing. We're going to say, yeah, allow notifications, and then add a notification to our schedule. We're running it through Chrome. We're just adding the notifications. We're scheduling them, and they're coming up inside of our notification center. So these are integrating with system features, and these are just using the web APIs. So let's just actually destroy our server, and we're just going to do a quick build of our app and deploy it to iOS. Okay, so typically this goes by much quicker due to build times. We're just going to skip it and just actually run the app that we have pre-built, which might look a little bit different, but it'll still give you the same effect. So our app build was successful. If you've never seen Xcode before, this is Xcode. It looks like a standard IDE. It kind of also looks like iTunes. So it's not too scary. It's fairly simple. But we have our app running. It's loaded up inside of our simulator, and let's just call add notification. So app would like to send you notifications. Allow. Let's see. Let's wait a little bit, and let's just schedule a notification. So right now we're calling schedule notifications under the hood, and we have our notification interacted with the native notification system. So this just works. I'm not having to change how that behaves, how that works. It's just, it handles it. So for the demo part, this is pretty much what I have. The code itself is not overly complicated. It's just calling in a few standard APIs. Let's go back to the slides real quick. So one of the big things about Capacitor is that not only can you deploy to iOS and to Android, but you can deploy to the web as we just saw. The APIs and features all exist and are supported in the standard web deployment environment. So if you want to add things like camera support, Bluetooth, file system, there are web APIs for this, and we support those as well. So you can truly build cross-platform without having to have, okay, well, here's my web version, and then here's my native version. A lot of those features, for example, we have some plugins for Toast, modals, action sheets. We actually supply the UI for that in the web layer using web components, so that way they're not going to be dictated on a particular framework. So if you are using Angular, you'll still have that features working. If you're using no framework at all, you'll still get those features provided to you by the web components. And if you want to play for more than just iOS, Android, and web, you could also deploy to Electron and still have these same features working. Electron is still early on in its development, but it provides a lot of promise. So if you have an existing Angular project right now and you want to try it, you can just run ng-add capacitor Angular. It's going to go through and actually modify your project, add the dependencies, and create the configuration file for Capacitor. Now, this has kind of been a whirlwind of a run through of Capacitor. I don't expect you to understand all of it right away or to want to use it right away, but take a look at it. If you're doing cross-platform development right now using things like Cordova, you could use your Cordova app inside of a Capacitor project without having to replace anything. Capacitor really just tries to solve the problem of, I want to build one code base and then deploy it for all these different platforms and not have to worry about, okay, well, I'm writing this kind of UI. I don't care about the UI. I just need to know, can I call the camera on iOS, Android, web, the desktop, what have you, and have it just work. So if you are interested in it, evaluate it. Check out our docs on Ionic capacitor.ionicframework.com and build out some prototypes and see how you feel about it. If you have any questions, I would love to take them now.
Awesome. Thank you very much, Mike.
Again, I do want to apologize for the fire alarm. I was not preparing for that.
No, but it was all right. We didn't hear it that much. It was like... so does anyone have any question?
Hello, Mike. Thanks for being here with us. I have a fairly simple question. I used Ionic with the Cordova before, and like you said, one of the biggest benefits of using Ionic and Cordova was being able to have access to all those plugins. Last time I checked, and it was like a few months ago, all the plugins available in Cordova wasn't available in with Capacitor. Are you working on improving the plugin support or something like that?
Sure. So to summarize a little bit of the backstory there, we did go through and make sure that we supported all the core Cordova plugins. So status bar, the geolocation, all the core ones that you can get from the official teams themselves. And then try to support as many as we could from the community. The issue there is that the community can create some pretty unique plugins, which could cause some compatibility issues. If you've used Firebase, there's like 5 different Firebase Cordova plugins. So which one do we support? We don't know. And then there are some plugins that actually modify the native project in a, I would say, non-standard way, and they would say in a unique way. So there are some plugins that we can't support just because of how they are actually built and how they're added to the project. We do our best to support the core important ones, the ones that we think people should use. But if you want to add other plugins, I think there's an opportunity for the community to come together and build those features out for Capacitor specifically without having to rely on what I would call legacy technology.
Okay, thanks.
No problem.
I had a question about, I'm really, I like Capacitor a lot. I used it for a last project and it was totally cool. Was euphoric more than a long time, since a long time for hybrid development. And I wondered, I had an app where I took pictures from the camera and then you can upload them on a server. And as I see it now, you usually get the base 64 data of the camera. And did you ever have troubles? I don't know, some pictures can become pretty large. Do you know, or did you ever have problems of memory overload when the browser just treats the base 64 data? Because before with Cordova, we were able to, we had a file upload plugin, but I don't know if we should do something like this again.
So with base64, yeah, you can have some memory issues depending on the device. If you're using older devices that are limited with memory, file storage limit, the app itself can just slow down trying to process all that. One approach that we've been looking at and kind of suggesting is instead of using base64 strings, just use the actual file reference and save that to disk. When you go ahead and try to do an upload, you basically convert that file, that native file itself, to a blob, and then post that to your storage. So if you want to do things like like Firebase's files, full like native file storage, you are actually uploading a JPEG versus just storing a random string in their database. So it's better for the device when you are uploading it, and it's better for storage.
Okay, great. So I got like 2 questions, I guess. The first one is, how could you benefit from stuff like ARKit and things like that? Is that considerable or?
Yeah, so there's 2 different ways. You could actually pull in ARKit, like its API, and create a plugin itself. So at one point, you are just, instead of presenting a web view, you are pushing a native view that is using ARKit to actually render everything out. There's already a couple plugins that are out there and some blog posts that are kind of looking into this and finding out what's the best way to do this. There's also web features, for example, on iOS, where you can just load up actual 3D models and place them using just your standard browser APIs. So there's a couple different ways to look into this. The native plugin approach is one way. Might not be as cross-platform, where you would have to actually build out the native version, the native equivalent on iOS and then Android. The web features are a little bit more compelling, as I don't have to write native code, so that's always better. So yeah, there's 2 different ways to kind of do it, using the web features and then using ARKit or AR Core directly.
Cool, that makes it clear.
Yeah, thank you for the presentation. I might have missed something, but what's the point now to use Ionic now that we have Capacitor running on?
So what's the point of using Ionic if you have now Capacitor?
Yeah.
So Capacitor itself does not replace Ionic. Like Ionic, at its core feature, it's a UI library. It's giving you the components, giving you animations, all the things that you need to build out the visual aspects. If you want to build, say, a native app and have those features, Capacitor is just a library and a wrapper tool around your existing web app. So one doesn't replace the other. They can be used together and still create something successfully. Make sense? Cool.
And I guess it's the question that everyone is asking itself, and it's very serious, is why do you use Vim?
Because I started using it like 5 years ago, and everything else can't compete.
Oh, that's cool.
I won't even use VS Code or IntelliJ stuff. It's just not the same.
Do you share your configuration?
I do share my configuration stuff on my GitHub.
Cool. That's awesome. Thank you. I'll use it for my next trainings for people discovering Angular. Like, it only works with Vim. And I think, is there one more question here?
Just a question, because are you still working on the documentation for plugin development of Capacitor? Because when I did the Android part, I saw there were some things missing, like when you don't want to get the promise back, but rather callbacks. It's not really present in the documentation. And the question is, are you working on it, or are you waiting for pull requests maybe for the community, from the community?
Documentation is a never-ending process. So I don't think we'll ever be fully done. But if you have a pull request that you would like to send, or if you want to first raise an issue, open an issue on the repository, and feel free to tag me directly on it. I'll make sure it gets to the right people.
Great, thanks.
No problem.
Okay, I have just 2 last questions, and I think I forgot them, but maybe they can come back. Okay, so the last thing was about, it was a question we already had for the previous talk, and love your advice about the things to do and things to never do if you want to avoid your app update to be rejected from Apple Store, stuff like that. This is like a common question that keeps flowing.
So Apple themselves make sure they have a pretty detailed section in their terms of service. Basically, when you submit the very first time, that is like your snapshot. Your app cannot deviate from that too much. So, for instance, if you submit a app that is a children's learning app, and then you go and next thing you know, one day it is a gambling app or something completely unrelated to that original subject, that is going to get you banned. That'll basically get your app rejected. If you are taking something that is generally a website, but not using any native features, or basically you're loading stuff in an iframe, that is also not good. Your app should be a app-like UI and behave appropriately for those platforms. You shouldn't just be taking your entire company's website, loading it up in a iframe that's 100% screen real estate, and then expect it to pass. I don't think anyone would really approve of that.
Cool, that makes sense. So consistency.
Yeah, consistency and develop for the platform using its purpose.
Awesome, thanks. And one last question is, how can all this beautiful community, Angular, JavaScript, Ionic community, help Ionic?
I mean, I'd really love to see people just try it and share their feelings about it. If it's great, that's awesome. Tell us. We'd love to know. If it sucks, tell us. We'd like to know, what can we do to make it better?
Awesome. So the best way is to email you personally or share issues on GitHub.
Issues on GitHub are great. You can tweet at us. We're all pretty active on Twitter. Try it out. Let us know, and we appreciate the feedback as much as we can get it.
Okay, so feedback then. Thank you for your time, Mike, and bye. Thank you.